Okay, welcome back, and now let's do an application dealing with metalworking, and then I'll read you the problem, and then we'll jump in and explain all this. Okay, it says the figure on the board shows the dimensions of a round countersunk head rivet. Okay, the rivet is made of solid copper, which weighs 0.324 pounds per cubic inch. .324. Okay, so that's the weight of the solid copper rivet. Okay, now suppose we need to find the total weight of the rivet in inches. Okay, or excuse me, inches, ounces. We need to find the total weight of the rivet in ounces. Okay, so now, this is the cross-section view of the rivet. Okay? So it's circular. So rivets are round. So this part of the rivet is a cylinder, right? This part of the rivet is a frustum. Okay? So guess what? We are going to use this information to help solve for the volume. So we're going to have to divide this into two parts, right? So we're going to use this part and use this to find the volume of the cylinder, right? Use the formula for the volume of the cylinder. And then this piece, we're going to use the formula for finding the volume of a frustum, okay? And then we'll add those two together. So let's do the first volume. So we'll call volume 1, or volume of the cylinder, right? So the volume of the cylinder part is going to be what? It's going to be the volume. Well, think about it. It's going to be area times height, right? Area times height. So the area of the base times height, which is what? Circular. So it's going to be pi r squared h, right? So now this is going to equal pi times the radius. What's the radius? Well, this is the diameter. So the radius is going to equal 0.2215 squared times the height, which is 1.125. Okay? It's all in inches. Okay, so now, what's the volume of that part of the rivet? Let's see here. That's going to be 0.17340. 17340. That's cubic inches. 0.17340. Okay, now the volume of the frustum part, this part. So now we've got the height of the frustum, that's given here. We've got the diameter of the frustum. Now we've also got the diameter of the other base, which is, again, it's part of the cylinder. So this is going to be 0.0443. Okay, so now we've got radius 1 and radius 2, if you will. Okay, it really doesn't matter which one you make R1 and R2, it doesn't matter. But this is R1, let's call this R1, that's going to be 0.2215. And this one here, R, is going to equal what? So this is the diameter, so R2 is going to equal what? Half of this, which is going to be 4113. Okay? Point. 411. Not 113, 115. I'm sorry. 0.4115. Okay? So now we've got R1 and R2. Now let's use the volume of the Frustum. So that's going to be what? It's going to be 1/3 pi times h times the quantity R1 plus R2 plus R1 times R2. Okay, so now we just fill in our information now. So it's 1/3 pi times the height. The height of this is 0.186. 0.186. And then this is going to be what? It's going to be 0.2215 plus 0.4115 plus the product of the two. So 0.2215 times 0.4115. Okay, and then of course we can stick all of this in our calculator, right? And we get 0.06029. Okay, so now what's the total volume? Well, we're going to add these two, right? So we add these two amounts, and our total volume, so the volume equals volume of the cylinder plus the volume of the frustum. And so we add these two, right? So we add the 0.17340 plus the 0.06029. And so we get a total volume of 0.23369. 0.23369. Hold on, I think I wrote that wrong. Yeah, I wrote it down right. 23369. So that's that's cubic inches. Okay, so now we're not done because they want the total weight. This is the total cubic inches. We want the total weight. So what are we going to do? This is the total volume of the screw in cubic inches. This is the weight per cubic inch. We want this is density, right? This is not the weight, this is density, right? So this is the density of the copper that the rivet is made out of. Okay, my mistake. So now we're going to use this density because it gives us the weight per cubic inch. It's mass per cubic inch of volume, which is what we're going to use for weight. So now this is our total volume. This is the density, which gives us the weight per unit volume. We're going to multiply these two together. Okay? So again, if you don't see it, just do your unit conversions, right? So the volume that we end up with is 0.23369 cubic inches. And so we want weight. We want the total weight of the rivet. Well, we're going to use the fact that density is for every cubic inch, right? That's what this is saying. For every cubic inch, I have 0.324 pounds. Okay? So these are canceling. So again, look at that. We multiply, just like I said. So if we multiply these two numbers together, we get a final answer of approximately 0.0757. So we get approximate answer of 0.0757 pounds is the weight of the rivet. Have a good day.